Great, thank you. All right, there we go. Okay. Hey, yeah, love to talk about case studies, love to talk about what's happening at real companies. Since I've been at Amazon for 13 years as of 2 days ago, that is what I tend to talk about a lot. I spent a few years at Microsoft, and I started out actually back in 2005, and that was before AWS existed, so I was working on the .com side of the house. But even as recently as a few years ago, I was working with dev teams across .com on how they use and adopt AWS. So like traveling over the world and helping with their architectures. So I wanted to share some of that with you today with a focus on how to do DevOps, how Amazon does DevOps. There's many ways to do DevOps. So I figured if I put up a slide like this of a wall at a DevOps conference, you all know what that means, right? I could have done a silo, I guess. But anyway, development, operations, they have to be able to communicate, they have to share common goals, we have to break down that wall, right? Well, at Amazon, the model, or sometimes it's called the topology, that they've adopted is you build it, you run it. So that's a pager. It's a real Amazon pager. You could tell from the wear marks on it, from someone who's been on call. So teams, development teams, they would build stuff. They'd have a rotating on call, and they'd have to fix problems in production when they arise. And that meant that team owned everything from design and coding and implementing to deploying and operation, end to end. So that means that at Amazon, there's really no ops role, and there's no DevOps role. Now, everything has asterisks, everything has exceptions. There's always exceptions, but in the general rule, when you're talking about the culture of Amazon, it's about a single team that owns everything you see on those sticky notes. And that single team is called the two-pizza team. Why two pizzas? Because they didn't want to be prescriptive about the size of it. They said, how about a team that could be fed by two pizzas? That could be a team of 5 people or maybe 12 people, but it's not 2 people and it's not 20 people. So this is giving the team autonomy on how to build itself. And that's the team that owns everything end to end. And there's a couple of cultural aspects of the two pizza teams that are really important. They have ownership. They own one or more services, and it's their services. So they have the autonomy to choose the technology that they're going to use to implement that. They even have the autonomy to choose what features they're going to implement. And you might be thinking, well, how does a development team pick out what customer-facing features they need? Well, it's not a development team. It's a multidisciplinary team. It's developers, it's QA, it's UX designers, and it's product managers that understand the landscape and the customer needs. So it's all that working together. And they don't always report to the same manager, so it could be a V-team model, but it's a multidisciplinary team that has full ownership and autonomy over their services. And when I say that, I hope you're a little skeptical, right? I hope so everything I've been talking about is cultural, right? Cultural ownership, culture of autonomy, culture of the two-pizza team. But actually doing that sounds pretty painful, doesn't it, right? I'm going to own not only the design and the coding, but I have to now deploy it, and I have to own it in production. That sounds really terrible. I'm going to have to find my own deployment system and create my own deployment pipeline, set up my monitoring frameworks. That's reinventing the wheel. We sometimes call that undifferentiated heavy lifting. Undifferentiated because every team has to basically do it, but it's not adding value to the product. It's not adding something that a customer can see, right? So you want to reduce that, right? You don't want to put this burden on all these teams so they're all reinventing the wheel. And that's the key of what I'm going to talk about. Everything up until this point has been culture, but I want to talk about how you take that culture and make it actually a reality. The culture is always first in DevOps, but you need to give your team the tools in order to make that culture a reality. And it's not just tools and frameworks, but it's teams' tools and frameworks. Because if you give them a tool and there's nobody responsible for that tool, there's nobody who owns it, there's no one the team can go to when it's not working, that's not going to work. So I'm talking about the use of centrally owned, responsibly owned tools and frameworks that are used by the two pizza teams. 2PT is two pizza team. The two pizza teams at Amazon. And there's several models. There's a model where you could just be using a third-party tool and have a team internally that owns the administration of that. That's not a common one. Amazon tends to build a lot of their own stuff, a lot of their own tools. And I'm not saying that's the right model. There's 2 reasons for this. Number one is Amazon goes back to 1995, so they've been building tools like this before they were even available in the marketplace necessarily. But the other one is now at the scale and complexity of Amazon. It oftentimes makes sense to build their own tools and not use third-party, or a hybrid model, right, where they take a third-party tool and they write a wrapper around it. I'm going to share an example of that later to make it meet the needs of Amazon. So these two pizza teams that own the creation and administration of these tools used by other two pizza teams that are developing product and maybe even tools of their own. So also they could deliver more customer value. And this here, who's seen this slide before? Anybody? No? All right, that's the Amazon architecture. Every dot on there is a service running at Amazon, and the lines between them are the lines of dependency. Now, I look at this and I say, Amazon's going to crash tomorrow. I should sell my stock today, right? There's no way that could possibly be viable. But it is. It runs. And how does that happen? I think it's like, I like to think of it as a fractal model. In other words, each of those dots, or one or more of those dots, is owned by a two-pizza team. They have responsibility for it. That two-pizza team is in an organization of multiple two-pizza teams working with each other. So they work on how they lay out their dependencies for each other and how they develop features for each other. And those organizations are within a department, which then rolls up to the company. So it works because of the ownership at multiple levels. And for our first example today, I'm going to talk about the Amazon detail page. Now, the last slide I got no takers. Who's seen one of these? A detail page. Yeah, most everybody's used Amazon. All right. Who hasn't seen one of these? Who is never going to raise their hand no matter what I say? Okay, there we go. So that's the place you buy stuff on Amazon. I just bought one of these Fire HD tablets after I left my previous one on a plane. That's the nice thing about the Fire tablets. They're kind of disposable, unlike an iPad. So, you know, I highly recommend it. You lose one, so what? You buy another one. And the thing about this detail page, which is so important to Amazon, is that everything you see on here is not owned by a single team. What is owned by a single team, called the buying experience team, is the framework. The framework that renders this page makes hundreds of calls to microservices, which we call widgets, that are owned by different teams. So for instance, I could bring up this page using an internal debugging tool, and it looks like this. Now you can see that the image is coming from the image block service, or the title is coming from the title service, or the average review is coming from the average review service. Now, hundreds of these calls are being made in parallel and with really low latency. That's the #1 commandment of the detail page. You can add a widget, but you can't add latency. And this is a really good model for a couple reasons. Remember, we're talking about resilient architectures too. So this adds to resilience in a couple ways. #1, well, it adds to agility. Teams can deploy independently. They're not dependent on other teams. But it adds to resilience because of something called graceful degradation. I'm going to come back to this again and again. Graceful degradation means that as long as I'm not losing something critical, like the title or the price or the image, you could still make a purchase. You're getting a degraded experience because you might not be able to see the Amazon's Choice label of, oh my gosh, you can't see the Amazon's Choice label, whatever you're going to do. You can still buy the tablet. And that's called graceful degradation, where certain things can fail, but you remain available in a gracefully degraded state. But it's also about, it's about the agility and it's about the resilience. Example 2, I'm going to talk about Amazon search. If you got to one of those detail pages, you probably got there by placing a search. So I'm going to search for chaos engineering for no reason. It might be apparent later. I get over 1,000 results for chaos engineering. Now, search, I was talking about massive scale and complexity, serving 300 million active customers, 84,000 requests per second at peak on Prime Day a couple of years ago. So a complex system consisting of about 40 back-end services interacting with each other. And I searched for chaos engineering. Who here knows what chaos engineering is? Who doesn't know? And I already know who's not raising their hand, so I'm good. All right. For those that don't know, this is it. From this book, and then it was also taken from this book and put into something called Principles of Chaos Engineering, which you could look up later. Discipline of experimenting on a system in order to build confidence in the system's capability to withstand the turbulent conditions in production. What does that mean? It means, hey, it's a mess out there. Anybody who's deployed anything in production knows it's crazy with users doing unexpected things and network outages and equipment failures, so turbulent production. How do you build your system so that you're sure it's resilient against those? You inject faults. You actually simulate these faults that would happen in production in your system and assess how your system responds in a controlled, scientific way. That's chaos engineering. And search has a search resilience team. Unlike the buying experience team, they don't have their own logo, so I made one up for them. And this is an operational excellence engineering team that's serving the 40 teams in search, and actually 40 backend services. I don't know if there are 40 teams. A team can own more than one service, but there are 40 backend services. And they're a two-pizza team. They're an example of what I was talking about, a two-pizza team that builds tools and processes so that the rest of the search teams could be more resilient and operationally efficient. And so they drive the resilience of Amazon search services, and we're going to focus on their efforts to drive chaos engineering and help the teams in search do chaos engineering. And if you're going to do chaos engineering and you're running on AWS, a good place to start is with this, the fault injection service. The AWS fault injection service, this is a good example of something not built by one of these teams. I mean, it's built by an AWS team, not built by an Amazon team, but this is a publicly available service. Anybody using AWS can use FIS to do chaos engineering. And it allows you to pick your targets. Are you going to target EC2 instances or Lambdas? Are you going to target the network? It allows you to specify actions. Are you going to simulate a failure or latency? And this is the important thing, safeguards and controls. If you don't have a objective measurement, a metric that you're measuring when you're doing chaos engineering that you watch, then you're not doing chaos engineering right. Because you have to watch that metric, and if that metric goes into the red, you have to stop the experiment and roll back. That's the guardrails. And you could use these templates to create experiments. Now, while I said they were going to use this, they're going to adopt that hybrid model I was talking about. They're going to take this, and they're going to build around it to help it make it easier to use for search teams. And they want the examples of kind of chaos engineering that search teams are doing is up there. So using FIS, they might be, they're running containerized workloads. So they might drain all the containers off a node. Or they might just kill a server in EC2 instance. Or they might inject latency. Or they might turn off a port. But they also wanted to do other kind of experiments. They wanted to do load testing. They wanted to do emergency lever testing. So emergency lever testing, what's that? I'll tell you in a couple of slides. So here's fault injection service, FIS, at the center, and they built an orchestration model around it, orchestration product around it, a tool, a framework, that was serving all of those 40 search services. So number one is, in addition to the FIS experiments, they wanted to be able to do other experiments, so that's number one. They wanted to provide a graphical user interface so that anybody can see what was happening at any time, including management, but also an API so the teams can onboard onto it. They wanted to be able to run it on a schedule. FIS does that natively. That was added as a feature now, but back then it was a little more complex, so they wanted to make it easier for their team, so they built that into the orchestrator. They wanted to be able to run it as part of their pipeline. FIS does that with many pipelines, but Amazon internally has its own pipeline framework, and so instead of having every team have to integrate with that, they created the integration as part of the orchestrator, and search teams just onboarded onto it. Now this one's important. Guardrails. Remember I talked about what guardrails were. They're the things that you're measuring to see if you're going out of bounds, and if you do, you have to roll the experiment back. Every team in search was required to specify a service level objective. That's a metric that is critical to that service. And the search resilience team was already tracking those SLOs. So it made sense to take their tracked SLOs and make those the guardrails for the chaos experiments. And on Cord, many of you may have heard this literally from the Toyota production system, from car factories, where they enabled any worker on the line to pull a physical cord and stop the line if they saw a quality issue. Similarly here, anybody in search can go into the tool and stop all chaos experiments if they see something starting to go wrong. And metrics and insights. Of course, the tool generates metrics, but they wanted to roll it up amongst just the search services to share the management. So this is what their requirements were, and this is what it looked like. So you can see FIS over here, right? So they're using FIS. To the right of FIS are just some example services that they're injecting fault into. The box on the left is the chaos orchestrator. And on the chaos orchestrator, you can see there's an API gateway. So they're presenting that API, and they built the UI in front of it. There's an and-on API. There's a scheduling capability using Lambda, which is serverless compute, and using DynamoDB, which is a NoSQL database. So they built this all into the orchestrator, wrapped it around FIS to enable those 40 search teams to be able to onboard easily and use chaos engineering in a consistent way. And that resulted in better resilience, because having that continuous evaluation and understanding of your resilience posture is crucial. So remember emergency levers? That's one kind of experiment they wanted to run, and I didn't explain what it was. An emergency lever is something that you do to take the pressure off your system if your system's in distress. You start to see things brown out, you could pull the emergency lever and it'll help. So for instance, the front end of Amazon, not necessarily search, but the front end might have an emergency lever to stop all robot traffic. So some robot traffic is good, like some is bad, but some is good, so they allow it. But if the system's under stress, turn off all the robot traffic and let the real humans get precedence. That's an example of an emergency lever. In search, they had a different emergency lever they used. So this is a search page for Lego, and you can see it returns all kinds of Lego sets and their prices and their ratings and their shipping options. But if search is under stress, they could pull an emergency lever that turns off non-critical services. So you get the price, the image, the title, everything you need still to finish your search experience. That's that graceful degradation again. So you get the emergency lever, alleviating pressure on the system. And guess what? Emergency levers are a centrally supported feature across Amazon because there's a team that owns an emergency lever framework that teams can onboard onto. And this is part of Chaos Experiment. They do a Chaos Experiment where they load the system up until it's almost going to fail, pull the lever, and see that the lever helped. All right, our third example is the Relay app. So who's seen these big rig trucks out on the road with the big Amazon swoop on them, right? Now, these are not the trucks that are going to be delivering stuff to your home, right? The stuff that delivers stuff to your home is called last mile. This is called middle mile. This is about delivering stuff, pallets of stuff from the warehouse, from the vendor's warehouse to the Amazon warehouse, or between Amazon warehouses. So there's this very sophisticated computer model built up over many years about what stuff goes where. There's hundreds of fulfillment centers in North America alone. So deciding what stuff goes where so we can get it to people as soon as possible is a sophisticated computer model. But unless you actually put the stuff there, unless you actually act on that model, it's just an abstract model. This is an app that makes that model real. It's an app we put into the hands of truckers, and it tells the trucker where to go, what to pick up, and where to take it. It generates a key that gets them into the fulfillment center, into the yard. It gives them directions. So that's what this app is about, the Relay app. And here's the architecture for the Relay app. Where the arrow is pointing are the back-end services. They call them modules. There's about a dozen of those. So like I mentioned a couple, there's a GPS module. There's a gate key module. There's a load designation module. It tells you what to pick up and where to pick it up. There's a chat module. So all these back-end services. And then there's a front-end gateway that provides an API to the app, to the mobile device, depending on which API call the app is making. It also does some authentication logic, you can see there. And the thing to keep in mind here is that each module and the gateway are built using separate infrastructure in separate AWS accounts deployed using separate pipelines. There's no shared ownership between them. And that makes this a framework, right? The gateway folks have created a framework where if someone wants to develop a new model, there's a prescriptive way they can develop a new model and onboard it into the app. And they wanted to improve resilience by going multi-region. Do you need to go multi-region? Not necessarily. AWS has multiple regions all over the world where they host AWS services. And you could probably achieve your resilience goals in a single region. But for the most extreme resilience cases, multi-region can be the right approach. So they were operating out of the East region, and they wanted to add the West region, so they'd be operating out of both those regions. For a given module or backend service owned by a given two-pizza team, they were given a choice whether to go multi-region or not, depending on their criticality. Critical services were asked to go multi-region, and that involved things like deploying the Lambda encode to the two different regions, deploying DynamoDB, which is, again, NoSQL database table to each region. And then we have a feature of DynamoDB called global tables that will synchronize the data between regions automatically. So that's the way that individual two pizza teams could look at their module and design it to be multi-region. And you ended up with some teams, the critical ones, like Module A here, that went multi-region, and some teams, like Module B, that did not. So this is an active architecture. It means that if you're a trucker on the East Coast, your request goes to the East Gateway, which means that Module A serves you from the East region, but Module B also serves you from its East region. If you're a trucker on the West Coast, it goes to the West Gateway and goes to the West version of Module A. But what about Module B? Well, it's still served from the East. This is fine for an active architecture. There's not a problem there. Another way to increase resilience, though, is if they determine that there's something going on in the East region, and they're not operating at their peak capacity, they're not operating optimally in the East region, they can fail out of the East region. They can turn off traffic to the East region. All traffic in the US goes to the West region, goes through the West gateway to the West module of Module A. Let's say Module A is the module telling them where to go and what to pick up. It's critical. So it goes to the West region, they get their load information. What happens to Module B? Module B maybe is the GPS directions. Well, maybe it works, because they failed out of Region East. It doesn't mean the region's hard down. Regions don't go hard down, right? So they failed out of the East region. Module B might still be working, but even if Module B is not working, there it is again, graceful degradation. So the trucker doesn't get directions. They'll go to Bing or Google to get their directions. And to stress again, these are all independent two-pizza teams and services, each in their own AWS accounts, operating independently, and this is enabled by another team called Builder Tools. Builder Tools builds tools for all two-pizza teams across Amazon. There's a way to vend AWS accounts with infrastructure in them. There's pipeline infrastructure, deployment infrastructure, all supplied centrally by Builder Tools, so each of these teams can operate with these independent services. And I talked about, it's everything we talked about before, right? Independent deployment, graceful degradation, and adding this new resilience capability, failover. And I talked about vending accounts and infrastructure. Well, the way that we don't really vend infrastructure, we vend templates at Amazon. And so they built a system with these infrastructure as code, another big DevOps concept, infrastructure as code templates, you can see some of them here, that are pre-created and pre-vetted. They're checked by InfoSec, not checked by InfoSec, but they're checked to be compliant with InfoSec and all the security requirements. They're checked against well-architected, that are following well-architected best practices, built in CDK or CloudFormation, so that folks, two-pizza teams who want to deploy infrastructure can choose one of these templates and deploy it with confidence. All right, in summary, Amazon two-pizza teams, they build it, they run it, but you can't just tell a team to do that. You have to give them the tools and frameworks, and those tools and frameworks need to be supported tools and frameworks, such as from the buying experience, the Amazon Search Resilience team, or Builder Tools, and that's the way a two-pizza team can do everything from coding and implementing to building, deploying, and operating their workloads. All right, some resources for you. There's some blog posts there, some videos. I don't know if we're going to share these slides later or you want to take a picture of this, but if you want to learn any more about some of the examples I gave today or just more about what I was talking about how Amazon does DevOps, there's some resources for you. And I think we have time for a couple questions, right? Yes? All right. Don't be shy. Questions? This is your chance to get inside information. Is this being recorded? Okay, it's a chance to get carefully crafted answers about inside information. You want the good stuff, you got to buy me beer later.
Got a question there in the back?
How do you get started if your system is much smaller than Amazon? That's where you don't necessarily want to build your own, right? You want to look at the examples of what's out there in open source, what's out there in enterprise software, make assessments of what tools can help you. But I still think the ownership model is important. So I still think you need an internal team, it might be a team of 2 people or even 3 people that own that tool internally and its use and administration so that other teams that are dependent on it can get quick responses and answers. And eventually, that's a great model because you evolve. As your team gets bigger and needs get complex, either you ditch that tool for something you build internally, or you build something around it, like the Search Resilience team did. Okay, other questions? Okay, there's a question over here. All right, yeah. Woo. Is that thing really a microphone? All right. Yeah. Doesn't work.
Nope. It's working.
Can you talk about some of the requirements that Amazon has for its two-pizza teams around documentation?
Requirements for documentation. So you mean like internally around its APIs that other services are integrating with, or what do you mean?
how all these services work together, right? There has to be good documentation so that Team A can utilize service of Team B, right?
Okay, so I don't know, you might have heard of something called Coral. So there's an internal framework that's been around for years. But again, when I say something's been around for years, it's not necessarily old and crufty. They're constantly improving it, right? And Coral is the inter-service communication framework. So you onboard onto Coral. That's a normalized way to expose APIs to other services, and it self-generates documentation about those APIs. In addition to that, teams prolifically use wikis. They have every team has a service dashboard that's showing their operational metrics. So it's another framework answer, right? The Coral framework plus culture of documentation results in it works. No, we can't use the cube. No cube. Real mic.
Go for it. Does Amazon have like a standard or a best practice for the amount of services that a two-piece team can own and operate?
Oh, okay. How many? Yeah. All right. I don't have to repeat it. You heard it. No, but it's up to the team. That's that autonomy. But they have to be able to justify it, right? Some teams own one. It might be a service that is complex or has a high operational overhead, which they should fix, by the way, right? So it might be one. A team wants to own 3 or 4. That's unusual, but it might be justified in some cases. Like some of those widgets you saw on the detail page. I think they might have 3 or 4 of those owned by a given team. Another example is IMDb, which I've talked about in the past. They went from a monolith to a microservices architecture, and they farmed out, like one team owns the service that vends the information about movies. Another team vends the ratings information. Another team vends the information about like searching through the movies. So it depends on the architecture and the teams. I'd say getting above 3 or 4 would be odd, but if they could justify it, that's the whole thing about the autonomy and you own it. If you could justify it, you could do it.
Test. So I'm curious about chaos engineering. How long did it take AWS to spin up that platform for chaos engineering? And if you haven't started chaos engineering on your platform, what's the best place to start there?
All right, so to be clear, it was Search spinning up that platform for Search to do chaos engineering. Prime Video also spun up their own platform for Prime Video to do chaos engineering. So it wasn't across all of Amazon. How long it took the search resilience team, I'm not sure. I mean, I'll have to get back to you on Twitter or something. I mean, but I would guess a couple of months from design to launch. Probably the harder thing than the technology was probably culture, getting the teams onboarded, like not onboarded like technically, but onboarded like, yes, we need to do this, right? So I think that was probably a big challenge. When you were asking, like, if you don't have this, what do you do? Again, start with something out of the box. You could use Chaos Toolkit, which is open source. You could use AWS Fault Injection Service if you're on AWS. There's a lot of good options out there already. But culture is usually important. You could start with the tool, but people don't understand what you're doing. Why are we doing this? Why are we breaking stuff? You have to explain, we're not injecting chaos. That's the misconception about chaos engineering. We're not injecting chaos. We are injecting faults to protect us from the chaos that's already out there.
All right, one more question. One more? All right.
Hi. When you talk about I guess teams at that scale or that many teams, the things that come to mind are like, how on earth do you keep the quality and the way like kind of in sync across the board? So you mentioned like independence, every team's able to do that, but if you have something you discover from research or whatever, like, oh, don't do it this way, and you want to flood that through thousands of teams, how do you keep that like best practice-ish mindset and let teams kind of adopt those versus like just completely doing whatever they want at all times, I guess, if that question makes sense.
There's a few ways. One is simply through automation. If it's something that is deterministic or security related, resilience related, there are scanners and various tools that can do static analysis or check your pipeline to make sure it's continuous and send you alerts or tickets depending on how dangerous it is to get that fixed. But for the more esoteric kind of stuff, like just practices that you can't physically test, there's 2 ways. There's education, right? So for instance, the consumer org has written a whole internal consumer engineers handbook that all new engineers are required to read and understand. But there's also process. So teams go through various review processes before they launch new services or major features, which are literally like these quizzes they're going through. Do you have observability at all layers? Do you have a process for escalating, issues? So they have to go through this. So there's basically three things. There's automation, there's process, and education. All right.
All right, thank you very much, Seth.
All right, thank
Appreciate
you.
it.
All right.